Hi class, in today's video notes we're going to be talking about how to find the volume of rectangular prisms and cylinders. Now as we did with our previous notes last week, remember that you need to have a piece of paper, a pencil, and some way that you can make some calculations, whether that's on a Desmos calculator like I'm going to show you today, or on your phone, or if you have a handheld calculator at home as well. So please make sure before you start this video that you have all the materials with you so you can follow along, take your notes, and make your calculations. Now, as I said previously, we're going to be working on volume of rectangular prisms and cylinders. So typically, if we were in class, you would have your formula sheet and you would be using specific formulas to solve for the volume of the prism or the cylinder. And these are the formulas that you're going to be using. For the rectangular prism, the volume equals the length times the width times the height. Now for a cylinder, the formula we're going to be using is the volume equals pi times the radius squared times the height. So on your notes paper, make sure you have those formulas written down, you star them, you box them, whatever you need to do to make sure you're using the correct formula. So before we get started with solving things, let's think about what volume actually is. And volume is the space inside a 3D figure. Now typically you would be seeing volume in real life. Maybe it's the cereal inside of a cereal box, or you're filling up a pool. Whatever is going inside of the figure, that's going to be what your volume is. So I'm going to say water in a pool is going to be our example. Now you might have noticed already that the volume formulas for these figures are both pretty simple and a lot simpler than the surface area, so hopefully today's a little bit easier for you. The first figure we're going to be talking about is the rectangular prism, and as we talked about before, we know that a rectangular prism has a length, a width, and a height. Now looking back at the top of our paper, we know that the formula for a rectangular prism is just multiplying those three values together. So volume equals L times W times H. Now what we have to do when we're looking at this figure is label which one is the length, width, and height. And I will tell you that as long as you label them and keep that consistent, it doesn't matter which one is the length, width, and height. So I'm going to label 6 as our length. I'm going to label 8 as our height. And I'm going to label this 3 as our width. Now when I'm solving for the volume, all I need to do is simply multiply those three numbers together. So I'm going to be doing 6 times 8 times 3. Head over to our calculator here, 6 times 8 times 3, and we get that the volume of this rectangular prism is 144. Now when we're talking about units for volume, it is going to be feet to the power of 3, or cubed. And the reason it has that value for the measurement is that picture it's trying to put little tiny cubes inside of this figure. It would take 144 of them to fill up this figure to get its complete volume. Now for the second one that we have over here, it's the same exact idea. We're using the same formula of volume equals length times width times height. So I'm going to label my length, width, and height. And then I'm simply going to multiply those values together and solve it. Pause here, make your calculation, and then check to see if it's the same as mine. Hopefully when you did your calculations, you multiplied 7 times 4 times 15, and you get that the total volume of this rectangular prism is 420, and our unit that we have here is inches, and it's going to be inches to the power of 3, or inches cubed. That is our total volume for our second rectangular prism. The next thing we're going to be talking about is a table that looks like this, and here's the question that is going along with this table. It says, which rectangular prism has the greatest value? And we're talking about volume. So, looking at our table here, we have 1, 2, 3, 4 different rectangular prisms, and what we're going to be doing is solving each of the volumes. So the way we do that is we take our length times our width times our height, and that's going to give us our volume. So looking at rectangular prism H, We know it has a length of 5, a width of 4, and a height of 20. So all we need to do is multiply these three values together. So we're going to do 5 times 4 times 2. So 5 times 4 times 2. 5 times 4 is 20. 20 times 2 is 40. So this rectangular prism has a volume of 40. Now what we're going to do is we're going to solve for the volume of these other three rectangular prisms, and our goal is to figure out which one of these has the greatest volume. So what I want you to do is pause here and solve for the three remaining rectangular prisms, and then we're going to talk about how we figure out our answer. Now that you've made your calculations, we know that H has a volume of 40, I has a volume of 24, J has a volume of 168, and K has a volume of 72. Now to answer our question, we need to make sure we pick the one that has the greatest value, and comparing these volume values that we calculated, we can tell that J has the greatest volume because 168 is the greatest of all of these rectangular prisms. Now the next shape that we're going to be talking about is a cylinder. And a cylinder, you've probably seen it before, is like a soup can. So today we're going to be solving for how to find the inside of that soup can, or how much soup is in that can. So our volume formula for a cylinder is volume equals pi r squared h. So we need to be really careful that we're first using the radius and then we're using the height. Now for these problems, you're going to be using pi, and when we're using pi, we typically are using the value that estimates pi as 3.14. So looking at this first example, let's go ahead and label what we know based off of our picture. So looking at this cylinder, I can tell that this 4 is going from the center of the circle out. So this we can label as the radius, because we know that the radius is going from the center of a circle to its outermost edge. This 13 that we have right here, we're going to label as our height. It's how tall our cylinder is, even though it's at an angle. And now we're just simply going to solve for the volume. So we're going to do volume equals pi r squared h. And now we're simply going to plug in the values that we labeled. So volume equals pi times my radius that we just solved for was 4 squared times my height of 13. Now if we were to calculate this on our own, we would know that we would need to do our order of operations by squaring 4 and then multiplying across. Or we can go over to our Desmos calculator that we have here. And rather than using the pi button today, we're going to be using the 3.14. So I'm going to rewrite this as 3.14 times 4 squared times 13. So over here, I'm going to type this in my Desmos calculator, 3.14 times 4. To get the squared button, it's this one right here, 4 squared, times 13 as my height. And right here is the volume that you're going to be getting for your figure. So the volume of this total figure is 653.12 inches cubed. For this figure that we have here, we have a cylinder again. The difference of this cylinder and the previous one is in this one we're given the diameter. So we're given the length all the way across that bottom of the circle. So in order to get our radius, we need to go from the center point out. So it's going to be half of our diameter. So our radius is actually going to be 5. Because we take the diameter and we divide it by 2. So we're using the same formula as the previous problem, volume equals pi times radius squared times height. We know that our radius in this problem is 5. We know that our height is 9. So now we're simply going to plug it into our formula. So pi we know is 3.14 times my radius squared, so 5 squared, times my height of 9. Go ahead and pause here, make your calculation, and see what you get as your total volume for this cylinder. After making your calculations, you should have found that the total volume for this cylinder is 706.5 centimeters cubed. Now the next part we're going to be talking about is real-world examples for solving for volume of a rectangular prism and volume of a cylinder. So the first problem that we have here is a soda can has a height of 6 inches and the base of the radius is 2.5 inches. How many cubic inches of a soda can the can hold? So first off, we know that the shape of a soda can is a cylinder. So we know we're going to be solving for a cylinder. And it's asking us how much soda can go in the cylinder, so we know we're solving for volume. So I'm going to draw a cylinder, and then we can label what we know about this soda can. So on this soda can, we know that the height of it is 6 inches, so I'm going to label 6. And we know that the radius, so from the center point to the outer edge of this circle, is 2.5 inches. Now, all we have to do is use our volume formula. So volume equals pi r squared. So 3.14 times our radius of 2.5 squared times our height of 6. And you should get that the total volume of this soda can is 117.75 inches cubed. The next real-world example we're going to look at is this one here. A container in the shape of a cube will be completely filled with sand. The container has an edge length of 8 inches. What is the exact number of cubic inches of sand needed to fill the container? So we're going to draw a picture. It's talking about a cube, and we know that a cube is just a specific type of rectangular prism that is made from a square. So it has a square on every single side, so you can think of it kind of like a dice. So here's my really terrible drawing. Yours doesn't have to be good either. And it says that every edge length is 8 inches. So it has 8 as a height, 8 as a width, and 8 as a length. So the volume we know is length times width times height. Well, on our figure, we know that the length, width, and height are all 8. So we're going to do 8 times 8 times 8. Go ahead and pause here and make your calculation for the volume of this cube. You should have calculated that the volume of this cube is 512, and our unit is inches, so inches cubed. The last problem that we have here says the cross section of a pipe has a width of 6 centimeters and a height of 15. Calculate the volume of the pipe. So pipes we typically know are in the shape of a cylinder, so we're going to draw a cylinder. And a vocab word in this problem that you might be stuck on is the one that says cross-section. So a cross-section means that it's going from one end of the pipe all the way to the other end of the pipe. That is the cross-section. Now on this picture, is this cross-section our diameter or is this cross-section our radius? Hopefully you knew that the cross-section of this pipe is our diameter, so it's telling us that our diameter is 6. So if our diameter is 6, what would our radius be? Hopefully you know that the radius is the diameter divided by 2 or split in half, so our radius is 3. The last thing we know about this pipe is that the height of it is 15. Using this information and knowing that pi is 3.14, go ahead and solve for the volume of this pipe. Pause here, and once you have your answer, unpause the video and see if you got the correct calculation. Hopefully you were using the correct cylinder volume formula of pi r squared. We know that pi is 3.14. Our radius for this problem is 3, and then our height was 15, and we calculated a total volume of 423.9 centimeters cubed. As always, if you have more questions or need clarifications on these notes, please send us messages or go to office hours when they are. And good luck. Have a good one.